In this video, we'll be going over the memorization approach of word break. Let's go over the thought process. So, in the recursive approach, the solution is not efficient enough due to overlapping recursive calls. We can avoid overlapping recursive calls using memorization. Now, what do we need to cache? In each of the recursive call, we are checking if we can break up the word or can't break at each starting index I. This means we can cache I with can't break. So let's go over the pseudocode. So we're still going to create our custom class try_no, which will allow us to create our try. This will allow us to have a quick lookup of each of the words inside our word dictionary without generating a substring. Then before we implement our recursive approach, we're going to create an array memo, a Boolean array memo, to cache previously calculated results. And then we're going to implement the top-down memorization approach. And then what parameters do we need? We'll still need our current starting index that we're checking. We can break up the word, the input string, and then the root of our current try. And then we also need to pass in our memo, which is our cache. And then what's the base case? If I is out of bound, this means we have successfully broken up the word, then we can just return true. And then another base case is if memo I is not equal to null. This means we have already calculated the results for the current index, so we can just return the cache results. Then each of the recursive call, we're still going to create our node to keep track of our current location inside our try, and then we're going to iterate through the indices from I to the end of the input string, denoted as j, and then we're going to retrieve the current character at index j inside s. So if the current character does not exist inside node.children, this means the current word or the current substring does not exist inside a word dictionary, so we can just break from the loop, and then later we're just going to return false. And then we want to move down our current try, so we're going to set node to node.children.getC. Then if node.word is true, this means we have found one word. Then we want to recursively check if we can break up the word starting from index j+1. And then if the recursive call is true, this means we can break up the word, so we want to put true at memo I, and then we can return true. If after iterating through the loop and we have failed to break up the word, we can just put false in the current, put false at memo I, then we can just return false. Now let's go over the time and space complexity. For the time complexity, initially we will need to create our try, so it's w times k plus, and then in our recursive calls, there are n possible states for each of the starting index. So it's n and then times, and then we iterate through over n indices at each of the recursive calls. So it's n times n, which will give just n squared. Now where wk are the number of words and characters inside each word, inside the dictionary, and n is the length of the input string. So the first one is creating try, the second one is n possible states with starting index I, and then we iterate through n indices each. And in our space complexity, we'll first need our try, and then we will need our memo, which is O of n, and then our recursive call stack memory, which is also O of n. So we get this. The variables are the same as the one from above. This is our try. O of n is our memo, and then the O of n is our recursive call stack memory. Now let's go over the code. So we will create our memo here, new boolean array, taking s.length. This will be our cache, and then we pass it into a recursive calls. If memo I is not equal to null, this means we have already calculated the result before, so we just return the cache results. And then we're going to create our node to keep track of our current location, and then we iterate through the indices. We check if we have found the current character or not. If we have failed to find the current character, this means the current substring is not a word inside a word dictionary, so we can just break from the loop, and then later we can just return false. We will move down our try. If the current node is a word, this means we have found a word, and we want to check if we can continue to break up the input string from index j+1. If this is true, this means we can break up the word. So before we return true, we want to cache it at memo I. And then later, if we have failed to break up the word, before we return false, we want to cache it too. You pass it on memo here. Let me know if any questions in the comment section below.